start it and pause it. Okay, okay.
Okay, so we can probably start. Um, yeah. So now, so what I intend to do is like, I don't have a lot of problems, as I said. I had like 3, 4 problems. We'll be focusing mainly on approaches and setups. These are like quite integral part of code bash. It can like reduce your calculations to a great extent. So we'll like basically start by just like quickly going through the formula. I hope everyone like knows what slopes and things are. Is there anyone who doesn't know like coordinates and slopes? Okay, yeah. So I like assume what are those two slopes are. So like to show perpendicular is like 2, 5. Mm. Just a minute, like does anyone of you know how to do this dark thing? Someone said that it would be better to do dark. It looks. What is this? How do you operate this thing? Okay, never mind. Let's just start. Okay, so um so to show two lines are perpendicular, you can show that the product of slopes is -1. Then if you have like two lines with slope m1 and m2, the acute angle theta between them is like tan theta is equal to m1 minus m2 upon 1 plus m1 m2. And so like if you can like see that for tan equal to 9 theta equal to 90, this becomes 0, so that becomes like infinite. So you get this thing. Now, so if you have a point and like a line, like point P and line L, then the distance of point from the line, that is this distance, is given by like let line L be ax plus by plus c equal to 0, and this distance is given by mod of L of p upon root of a square plus b square. Okay, does everyone understand this notation? Hello, yes or no?
You are saying the distance is that L of P upon the
Yeah,
root.
so the L of p is just substituting these coordinates in p, L. That is like
Okay.
clear.
Yeah.
So like p, if p is x naught comma y naught, you just substitute x naught here, y naught here, and get the whatever value you have. Then this point, like the foot of altitude is given by x naught minus a times L of p upon a square plus b square. Like if p is x naught comma y naught. Like what is this? Comma y naught minus b times L of p upon a square plus b square. And if you want the reflection, you can just like use the reflection formula and things. So this would just become 2 if it was reflection, but like I won't write that. Then just a note that this coordinate system is like quite similar to complex. So if you have like you can just like replace this with say x naught plus I y naught. So whatever formulas you did in complex for which the real part and imaginary part don't interact, the same formulas would like hold in coordinate. I mean like the section formula and such things like centroid, etc., whatever. Okay, so this is what it was. What else is there? Okay, so if you have like two lines, L1 and L2, This is like a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Then the angle bisector and this angle bisector. These will be given by mod L1 of P upon a square plus b a1 square plus b1 square ka root is equal to mod L2 of P upon root of a2 square plus b2 square. This will be one of those, and the second one will be mod L1 of P. Oh wait, why am I writing? Oh, it's fine, it's fine. Mod L1 of P upon root a1 square plus b1 square is equal to minus of mod L2 of P upon root. So
I don't see how second formula makes sense. Both sides are positive. How can you have positive equals to negative?
okay, wait, I miswrote my. This is like not mod. Sorry. Thanks for pointing that out. Wait, I don't know why I wrote this. Okay. This is like now correct. Does this make sense now?
So wait, what is this for?
These are the angle bisectors. Like one of these is internal, one of these is external. Unfortunately, you don't have a very good way of identifying which is what. You just substitute some random point. Like if you take any point in this region, you substitute it in one of the one of these equations, and then get the corresponding formula like by the sign thing. Wait, did that make sense, or like should I rephrase it? So like you know that if you have this is a plane, this is a line, and this is like any point, and substituting this line like P1 and P2, then L of P1 and L of P2 have same signs. I mean both are either positive or both are either negative.
Correct.
So what you do here is like if you want to identify this angle bisector or something, take 1 point here, 1 point here, substitute and find out which is the which of them have different signs, and like for this you will require same signs. Did you
Yes.
understand?
Yeah, I got it.
Okay, so I mean you don't require these like you don't require this on a large scale, but it's like good to know. Okay, so we are done with these things. Now, like just a quick look at some not some setups, like what all you can do. Like you generally have a triangle, right? So, okay, so one thing that makes sense is to pick BC as the y-axis, BC as the x-axis, and A on the y-axis. So like this as the origin, and this would be like C comma 0, B comma 0, A comma 0, oh sorry, 0 comma A. This is like nice one because then like these equations of line AB and AC you can get immediately. Like AB is just what? Okay, yeah, AX plus BY equal to AB, and AC is AX plus CY equal to AC. So these are like the two equations. And then you can also get orthocenter pretty quickly. Well, like just you know this slope, then you can just like draw perpendicular intersect with y-axis, then you will get the orthocenter. Just the disadvantage is that circumcenter you don't get that easy. You will have to like do some acrobatics or something. I mean, if you can find orthocenter and you know GH polarity, or you can like find this midpoint. This is like this is b plus c by 2 over 0. Then like draw perpendicular and draw one of the perpendicular bisectors. You can either do that or, I mean, yeah, these are like the two methods. So like where you have only like lines and intersections, this method is like quite nice. Also, wait, I forgot to mention one thing here. Uh, if you have like a circle, like XY the diameter, and let this be like x1 comma y1, x2 comma y2. Then the circle with diameter xy is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Can anyone like quickly outline why this is true?
I mean, the center is the midpoint, so we can just like substitute into the like x minus a whole square plus y minus b, and then we can
Yeah,
find
I
it.
mean, okay, you can do that, sure, but like a better method would be like to for any point P, this angle is 90. So this like just you can rewrite it as y minus y1 upon x minus x1 into y
Okay,
minus y2 upon
no,
x equal to minus 1. That's just this condition of 90 degrees. So you get that. Okay, and like one more thing, if you have two circles C1 and C2, then the radical axis is just given by C1 minus C2. C1 minus C2 is equal to 0. Oh, okay, but by this I mean like this in the normal form plus 2g1x plus 2y plus C1 and square plus y square plus 2g2x plus 2f2y plus C2. Then the radical axis is just given by C1 minus C2 equal to 0. And power of any point A, like if A is any point here, then the power of A with respect to the circle is equal to just like you substitute coordinates of A in the circle. Also note that for these two formulas to hold, these coefficients have to be like 1. Otherwise, you have to like just divide and do that. This follows immediately from this. I mean, yeah, this implies this basically. One more thing, I mean, okay, this is like quite non-standard, so let's not do that. Okay, so we were like doing setup, so I just digressed a bit. Sorry for that. So another nice thing would be to another nice setup is to like take uh take origin as the origin as the like origin, BC parallel to x-axis, and like take a random. So A will be like some what x naught comma y naught, let's say.
Is that the centroid or the circumcenter? Like the
Circumcenter.
Okay.
Then B would be and B is like symmetric to BC is parallel to x-axis. So this would be like something minus B comma C and B comma C or something. Yeah, okay. And here you often like somewhere you'll have to use this thing, of course. And here, like since this thing is parallel to x-axis, then it becomes like easy to calculate put of altitude or something. Uh, and yeah, and even the orthocenter is like quite nice here. Orthocenter is just like x naught comma sum of these two, so y naught plus 2c. That is like standard complex formula, right? Like if or h is equal to a plus b plus c, just get by OGS collinearity. So you just get this is the orthocenter. Okay, so this is like another setup. Okay, so like these are like mostly the tools that you use. Otherwise, like you can derive anything on the spot if you want to. Okay, so like like before we start solving, there are like few things we should remember. Like always be on the lookout for synthetic observations. They can like reduce your calculations significantly. So like sometimes what happens is you do a whole lot of calculations, then you find something unexpected, then you see that okay, synthetically this was like trivial. So on that occasion, I would like to like write down the synthetic proof, because synthetic proof is like foolproof. Because like sometimes in calculations you make a mistake twice and that's how you get the correct answer. So like just to avoid that, if you can find a synthetic proof, I would write that and like maybe finish the rest by coordinate or something. But yeah, so like you shouldn't just switch off your brain. Just like always like look out for these because these can help you significantly. Second, like think of a good setup. By setup, I mean like coordinate axis and origin things. Good setup. This is like quite underrated. That's why, but this can like, as you will see in a problem, this can like significantly reduce your calculations. Uh, yeah, I mean, also like don't hesitate to improvise. I mean, okay, of course, in exam you are the best judge, but if you're like practicing and you're like almost done with the problem, then you realize that okay, this setup would have been quite better, I think, and like just finish this and like maybe try again with this setup. So you
Arnav,
will get
what's the meaning of a good setup?
okay, so like in a problem, just like we did here, so like you could set up, I mean, like you set up the coordinate axis, right? So here you did with circumcenter as the origin and VC parallel to x-axis and stuff. So like I like it on a different color. So like these are your coordinate axis. This is like your setup before you start trying, and here these are the coordinate axis. So like that thing this is like you have the freedom to choose what setup you want to make, right? So you have the freedom to choose origin and direction of coordinate axis. So appropriate choice would like help you a lot. Did that make sense?
Can we choose scale?
Yeah.
Like, are nice scales also important?
Sorry.
Are nice scalings also important?
Okay, I mean, yeah, scaling can be important. Uh, yeah, I mean, okay, you can say that. Like many times, like without functionality, you can assume the unit length of something to be right. Many times I prefer not to use one because like then you destroy the homogeneity. So if at any time you get like a square plus b term, you can be like quite sure that okay, you have made some mistake in calculation because like this can't be added.
Mhm.
But otherwise, I mean, I mean, yeah, but like unit length also helps sometimes to reduce calculations. But then you just need to make sure that okay, you can't get a square plus b, but you can get a square plus one sort of terms.
Yeah.
Yeah. Okay. So then, and like the third thing is I like to call this as the flow of the problem, like flow of the bash. So by flow, what do I mean is like how do you go about calculating? How do you go about proving it? Like the thing is that you need to plan your bash efficiently. So like let's say like there are some steps. Bash like so you will calculate A, then you will calculate B, C, D, and so on. So like these steps need to be clear in your mind before you start bashing. I mean, there can also be like different paths to do this. Like you can like first do D, then go do C, then do B, and so on. So like as you do various bashes, you will develop an intuition as to like what approach would be better to do. So that flow can help a lot. Also, by flow, I mean that if you have two variables, so like you have some quantities, let's say x and y, these are like dependent. So you can either take x as a variable and represent y in terms of x, or you can take y as a variable and represent x in terms of y. So which one of these would be more beneficial? That is like that you will have to decide. So it, you should like choose intelligently. Also, what do I say? Yeah, okay. So you also like you needn't. Okay, this is like important. So you need not calculate everything. I mean, that's like trivial, but we forget it many times. like you need to be sure about what things you need to calculate. Otherwise, you end up calculating points that you would that you could have just skipped. So like for example, you can like redraw the figure in such a manner that okay, this is like something, this is something, but now I need not calculate these points. I can directly use some other synthetic property to show to get this line or something. Like this line is maybe defined in the problem in like as intersection of this and let's some other line, let's say this, but then you find that okay, this is one line, this is perpendicular, and this is a fixed point, so maybe I can calculate this slope and do this and skip the calculation of these 2 points. Did that make sense?
Yeah, that makes sense.
Yeah, okay. So that's why like you need to plan your bash. Okay, so like now let's do a problem. Let me just copy paste. Okay, wait, so someone was like asking for a summary. So did you get what was being
Yeah,
discussed?
I don't need it right now.
Yeah.
I got it.
Give me a minute. Yeah. Okay, can you like see the problem?
Yeah, it's visible.
Yeah, okay. I'll give you like some time to think about it. I mean, I don't obviously expect you to bash the whole problem in 5 minutes, but you can like just think about maybe setup and ideas like flow or something. So if like anyone has any ideas, feel free to speak.
It seems that it's quite nice to have the altitude from A and BC being the y-axis and x-axis respectively.
Yes. Yes.
I mean, isn't it better to just take PQ and A? Like you take PQ, I mean, you take AP as one axis and AQ as another axis. That sounds better for some reason.
Yes. I mean, okay. These two are like the obvious choices. I'll just draw the figure.
I think taking D to be the origin is going to be a good idea. And BC to be the x-axis, and like we can assign the coordinates accordingly. And
Because if you think, then we could have a circle that has center A, then and radius AD. Suppose that's 1, and then you just have the unit circle which has P, A, and Q on the circle.
Yeah, okay. So these are like obviously the two choices for setups. Okay, so I hope everyone sees why this is 90. So these are like equal. dA equal to dPu equal to dQ.
Are you writing anywhere? Because
Oh,
I'm not able to see it.
wait. Sorry. Can you like see now?
Ah,
Can,
yes.
yeah. Okay. Sorry. So these are the two obvious setups. Either you take PAQ or you take dA dP dQ. Okay, so like I intend to do by both of these methods. So like without loss of generality, we'll do by taking D as the origin first.
Wait, but A as origin could also work out, right?
Yes, we will be doing that. We'll be doing that at the second method. We'll be doing this by both the setups.
Okay, just asking.
No, yeah, we will like, of course, we'll be doing that. So let's do let's say
But
method.
we can take D to be 0, 0, C to be C, 0, A to be 0, A, and like B to be minus B, 0, and something like
Yeah. Okay. So B is like. Okay, so one thing I prefer to do is not to take B as minus B comma 0 and to take only as B comma 0 because if you take minus B, you like sort of break the symmetry. I mean, yeah, it's on the negative side, of course, but like we don't care literally. So like,
Just asking,
yeah.
since we have D as the origin and dA is equal to dP is equal to dQ, would it be best to say that we can set AD to be 1 so that
Yes,
we can kind of cut off from the variables?
yes, we can do that. So you do this and then say A is equal to 0, 1, P is equal to minus 1, 0, Q is equal to what? 1, 0. Okay. So now wait, this is like XY, right? Have I read it correctly? Yes. Okay. Um.
I think if we're looking at the flow, then the next thing would be to find the equations of Px, Qy, and like we can take the midpoints of Px and Qy like to be Px, Bc, and Qy to be m1, m2, m3. So we also want to find the equations of Pm1 and Qm3. So that's
Wait. Could you repeat the last part?
like we'll take the midpoints of Px, Bc, and Qy to be m1, m2, m3.
Yes.
So now we want to find the like after we have found the equations of AP, BC, and AQ, we can find the equations of the lines that are perpendicular to those and passing through the midpoint. So those are just two of the perpendicular bisectors, right?
Yes. So that obviously makes sense. So now, of course, okay, these are like trivial. So let's write it on. Px is like x plus y equal to x minus y equal to 1, or y minus x equal to 1. So it's like y equal to x plus 1, and qy is x plus y equal to 1. Everyone sees this, right? Okay, so now here is the first important thing. So now you have like variable points x comma y, and you have variable points b comma c. I mean, okay, b comma c are not exactly variable points, but here, like in our calculation, they will be denoted by variables. So you can either take b comma c and represent x comma y in terms of that, or you can take this thing and represent this in terms of that. So what do you think is easier?
I think that first we have it x and y are diametrically opposite around the circumcenter of ABC. That might be useful.
Yes, exactly. So now you can like just assume x has to be some, let's say t comma t plus 1, and y has to be some u comma u plus 1. So now and now by the diameter formula, you know that the diameter of the formula is x minus t into, wait, sorry, I messed up formula of y. It's like y u comma 1 minus u.
And just to clarify, what are these x and y again? Like, what are they in the diagram?
They are like the intersection of AP and AQ with the circumcircle of ABC.
Oh, so we're assigning them variables. Oh, okay, yeah. I was thinking if we were having a new function or something.
No, yes, that's the thing. Like x comma y and b comma c are interdependent. Like you can reframe the problem as b comma c as the intersection of circle with diameter xy with the x-axis, right? Sorry, yeah, x-axis. So now you know that this thing, this is the formula. Wait, y minus u plus x minus u, y minus t minus 1 into y minus 1 plus u. And this is like 0. And now you want the intersection with x-axis. So b comma c should be the roots of equal to x minus t into y minus u, x minus u equal to 0. Right? Because, oh, sorry, plus some constant thing. I mean, we'll see why you don't care about this, right? Because y is equal to 0, right? For x-axis. So this just becomes x square minus u plus t into x plus some constant thing. So now also if you observe carefully, if these are B and C, we only care about the perpendicular bisector, and this has the equation x equal to B plus C by 2, right? Hello.
Yeah.
Like, so we just need the sum. That means the coefficient of x.
Yes, so we know that B plus C equal to U plus T. So we just get that the required perpendicular bisector of BC is equal to U plus T by 2. We don't really need coordinates of B and C. That's the point. So like you don't need not like solve the very dirty quadratic. So you just need this thing. And now, so another good thing is that you just need to now intersect these two lines and just get that the x coordinate is u plus t by 2. You need not even calculate the y coordinate of the intersection of the two lines. So now, okay, so now you know that slope of xp is equal to 1. So the slope of perpendicular bisector of xp would be minus 1. Midpoint of xp is what? What is that? So x is like t comma t plus 1. So this would be like t minus 1 by 2 comma t plus 1 by 2, right? Yeah, and this is like u and 1 minus u, right? So u plus 1 by 2 comma 1 minus u by 2. So now, and the point is t minus 1 by 2 comma t plus 1 by 2. So this would also by minus slope is minus 1, it's always x plus y is constant. So you get that x plus y is equal to this is the sum is like t. And for the slope of other things, slope of yp you know is yq you know is equal to minus 1. So the slope is so the other slope has to be plus 1, and so it's always x minus y is equal to some constant, and you have u plus 1 by 2 comma 1 minus u by 2, and by that you will get that this is equal to u. So now just like you get that x is equal to u plus t by 2, and that's what we required, and we are done. Did everyone understand?
Yeah, that makes sense.
Okay, so the key takeaways from this was like we like cut down our bash is this part where like because otherwise what you would have to do is you'll have to calculate circumcenter you'll have to calculate the circumcircle of B, C and A. That is like I mean you can do that, but it's like not very cool. Then after that you will get they'll have to intersect AP with that thing, and then take the midpoint of that. That would be like a bit tough. I mean, it would not be tough, but it would be more not clean. This is like quite more clean. And then you need not calculate actual values of B and C, but you only need the sum of that. And yeah, this finish was like just finish. Okay, so this was like a nice thing. But as someone had said, the second setup is like very, very, very quick. I mean, you will just see how quick it is. Okay, so now I'll to draw this, I will just like rotate the figure and make AP and AQ the XY axis. So this is like A 0, 0, P, Q, then you have what, X and Y. Oh, they're like inside now. Okay, doesn't matter. I'll just draw them outside. It would be better to draw. Okay, and so like B and C would be somewhere here or something. Okay, can anyone like try to describe the flow? Okay, also note that we can now completely ignore D because the only thing we require is that AQ equal to AP. So like only these two lengths are equal. That's all we require. Does that make sense?
Mm-hmm.
Yes.
Okay, so can anyone like just try to describe the flow, how we'll go about?
I mean, we could just like assume that P and Q are what? 0, 1 and 1, 0.
Yeah. Sure. Oh, sorry, one comes.
And then you can choose, then B and C just lie on that line. So yeah. So like we know the equation of P and Q, PQ.
Yes.
And then
BC is
PY.
not quite important for now, kind of.
Sorry.
Like B and C are not quite important right now because we already have what we need in the, the
Yeah, that is true.
XY
They
axis.
are not very important.
But we need
Also,
the
we could take
midpoint.
like,
Yeah.
sorry,
Go on.
we could take like XY as like the things because XY lie on the X and Y axis. So it'll be easier to compute from XY to BC.
Yes. Okay, now the thing is that it won't be sufficient to calculate just B plus C. You will have to now calculate like individual coordinates or something if you are going about calculating B plus C, B and C. Do you have any ideas regarding that?
You only need the difference of the coordinates.
Sorry?
You only need a difference of their coordinates.
Wait, I could not quite understand you.
You only need the difference of their coordinates.
Can anyone understand what is saying? I think my voice.
You only need to know the difference of the coordinates.
What do you need to do is difference of the coordinates. Are you
Yeah,
saying?
not the, yeah.
I mean, fine, but like there is more intelligent way of doing perpendicular. Like, okay, so you don't really need B and C, you need perpendicular bisector of BC, right? That's the same point. So can you now just think of how you can get perpendicular bisector of BC just in terms of X and Y without actually calculating BC?
Uh,
Doesn't perpendicular bisector of BC pass through the midpoint of XY?
Exactly. So you just need to calculate the midpoint of XY. I mean, okay, in this figure, it's looking like these are equal, which they're not. You just need to calculate this midpoint and drop a perpendicular here. That's all you need to do. You don't need to calculate B and C actually. So now, and these perpendicular bisectors are like directly obvious. So now it's like, I mean, okay, I'll write it down, but this is like just head bash. So if you did that, okay, I should have like written opposite, but it's fine. So it's like 0, x, y, 0. So this point would be like y plus 1 by 2, comma x plus 1 by 2. And midpoint of this thing is actually x by 2, sorry, y by 2, comma x by 2. And now you know that the slope of PQ is equal to -1. So slope of this
Yeah.
thing has to be 1. And so x minus y has to be constant, and clearly this x minus y is constant. Did everyone understand?
Yeah.
Yeah, okay. So this is like clearly head bashable. So this was the intelligent setup. I mean, as you see, this was quick, but it was not very quick. This is like insta bash. It just finishes. Okay, so that's why like setups are quite important and the flow thingy. Okay, let's move on to any questions regarding either of these or any other comments about this question?
Can you
Okay,
show the
let-
problem I joined late?
yeah, okay. So okay, I'll tell the source. This is
Is
India.
this India TST?
Yeah, this is the practice TST.
Oh,
24.
so wait, this is the projective and then pod bash,
Yeah,
right?
23 P1. Day one. Sorry, practice TST. Yeah, practice TST 1 P1.
This is the projective and then chord bash problem.
Oh, I don't know projective. I did direct code bash.
Okay. Since I remember, I heard there was one problem which you project with homography and then you chord bash. So I thought that was the thing.
Yeah, I don't know the solution for that because like
This
homography.
is perpendicular bisectors, so that won't be very.
Yeah, yeah.
Yeah, you can't do homography with perpendicular bisectors.
Exactly. Okay, maybe it was something else. I don't remember.
Yeah, it must have been a different problem.
Yeah.
That
Okay.
was proposed by P squared.
Yes, true. Okay, so let's move on to next question. Okay, like most of you must have done this, but I don't know how many of you did this in chord bash. It's like in mode 24 P1. Okay, one thing we need to discuss is that what made this problem ideal for chord bash. So things that chord bash is good with is 90-degree angles. And as you see, like you had a lot of 90-degree angles here. This is 90, this is 90, then the perpendicular bisectors, these are 90, etc. etc. So 90-degree angles, chord bash can handle it very nice. Also, you had like one circle. Chord bash is not very efficient with more than one circle or intersection of circles because then you have to like solve quadratics and something. So since this had only one circle, it was like quite efficient. Then another thing, what? Okay, never mind. I mean, okay, these are like things that made this quite chord bashable. And like no other angles were there. Like angle chasing and sort of stuff was not involved. So like non-90 angles were quite rare. Okay, so let's move on to next problem. This is like in mode 24 P1. How do you move this? I'll draw the figure. Okay, so there was really no need to chord bash this. This is like quite easy synthetically also, but I was like too dumb at that time, so I chord bashed it. Why did I draw it like this?
Wait, so we could have drawn like C on top, or like is there some setup advantage by drawing it like this?
No, I'm like just drawing general figure. I'll redraw the figure according to the setup later, if that's okay.
Yes, fine.
ECB is 90, so it's like diametrically opposite. Wait, what? Yeah. Um, Yes, so you have this circle and you have ECF. Have I drawn the figure wrong or something? This doesn't look familiar.
Okay, one possible setup could be to set C to be the origin, E to be on the y-axis, and B to be on the x-axis. That seems
Yeah, yes, that makes sense.
What does it mean that the circumcircle lies on the circumcircle? That
No, circumcircle of EGB. So this EGB ka circumcenter lies on the ECF ka circumcenter.
What I thought was to take the circumcenter of ABC as the origin, since that would give you a circle centered at the origin, and that would work nicely with 90-degree angles, because then we'd have a bit more freedom for the x and y axes.
Okay, but I don't really see why you are choosing that, because then if you think, so O will be somewhere here, then you will of course take BC parallel to x-axis, right?
Oh no! In my approach, I thought I put C on the y-axis and AB as the x-axis, like parallel to the x-axis.
Okay, wait, let me like redraw the figure. So you are taking like this thing.
Yes, yeah.
Okay, interesting. Yes, I remember I had this setup in contest. I didn't really remember it. I was trying to remember what did I do in contest, but I did not remember that. Yeah, interesting. I had like similar idea or something. So you're taking,
So did you? Yeah.
no, I don't remember what I did there. I don't know. But like, yeah. But yeah, it was this setup. Now I remember. Wait, so what was the figure? I forgot. You see,
So
like,
like we're going to have the center around the circle around O. So having O as the origin would be quite nice to have. Since then you have CO as the y-axis, and then AB would be parallel to the x-axis, etc.
yeah, and like the G point is, or wait, G or something is just diametrically opposite of B.
Yeah, yeah, that also.
Yes. Okay, so this was like one choice. Okay, we can try this because I don't remember the bash what I had done there. I reconstructed another solution at home later. We can do that also. Let me just like draw the figure. I forgot what was the figure. B parallel to C. Insert C. Okay. And then E, C, F, and E, G, B. Okay. Yeah. This is like 90 again.
What do you have to prove?
We have to prove that the circumcenter of EGB belongs to circle ECF.
Okay.
Okay, so like basically after some experimentation, you get that the circumcenter lies on CB. So you basically have to show that this thing is the circumcenter. I mean, I had got that by just like drawing a few figures or something. Okay, so this was that thing. Okay, now it makes a lot of sense why I had chosen this thing.
So proving the okay, if you take that point where from F where it intersects CB as H, then you could if you could prove that EFHC is cyclic, then we're done.
That is like trivial, no, it's a rectangle.
Put a perpendicular, I think,
Right,
would be better.
exactly.
You just need to show that this is circumcenter. Okay, so one thing this flow that now I remember is okay. So one thing I'm remembering that you don't need to calculate A. That's one thing I remember or something. Um, yeah, you don't really need to calculate A. So you take this thing. Oh, wait, or you might have. Wait, let me like just confirm.
Can you put a question for?
Right, like, Ajay, I'm saying something, your voice is too low. Okay, maybe I'll like remember later. So one thing what you can do is what he said. This setup is like quite nice because you get E directly by reflecting B about O. Then this is just parallel lines, which is quite nice. The intersection is quite nice. Then one thing you can get directly probably by just looking at the coordinates is that these two are like equal. Then one thing automatically gets that H belongs to perpendicular bisector of EG because these two are equal and per 90. And by chord bash, you can like just show that this midpoint also lies on H. So should we do this? Yeah, I mean, let's do this. There's no harm in them. Let's try this. Okay. So what do you have?
We first show the circumcenter is on BC synthetically, or you want to show it like complex? I mean, using coordinates.
What? Sorry?
Are we going to show the circumcenter H is like on BC using synthetic or like using quad bash?
No, like we are claiming this to be the circumcenter. So
Okay, fine.
yeah. So this is like then let's say b comma 0 minus b comma 0. Oh, sorry, not 0. What am I writing? A, let's say minus b comma a and b comma a. Yeah. So E you get to be minus b comma minus a. Then slope of CB is equal to uh wait, why am I getting slope? Okay, I'll require. It's minus.
So how can you assume that? How can you assume A is equal to minus B comma A and also assume C equal to 0 comma C?
Oh, sorry, what?
O is the origin, right? The circumcenter is the
Yes,
origin.
O is the origin.
How can you assume 0 comma C and minus B comma A and B comma A?
0 comma C I can assume because it's given CA equal to CB.
Oh, it's given at
Yeah, this is the problem. CA equal to CB. Is it fine?
yes.
Yeah, okay. So slope of CB is minus C by B. So from that slope you put the line through E, so you will get.
Isn't it A minus C by B slope of BC? Or am I making a mistake?
Oh, sorry. It's I messed up. Sorry. It's A minus C by B. Wait, is it A minus C by B or beta? Yeah, it's A minus C by what? Yeah, okay. A minus C by B. Then you just put a line through that, so it will be like y plus a equal to x plus b into a minus c by b, yb minus xa is equal to ab minus sorry minus of what happened minus of ab plus bc. Like just point any error out if you find I make a lot of mistakes. Okay, so then equation of probably G you get directly. G is like intersection with x y equal to a, right? So put y equal to a, then yeah, something looks this. Okay. So it's like 2ab plus bc upon a comma a, and then equation of a c, slope of ac is what? C minus a by b. You can solve these two simultaneously. I mean, okay, wait. Do we need to really solve? Just a minute.
Could you kind of like sum up the chord working we did till now?
Okay, yeah. So what we have done is calculate slope of CB, but I'll just do a different color. So you calculate slope. Did you understand the setup?
Yeah, the setup makes sense.
Yeah. So now you calculate slope of CB. Then you know the coordinates of E, so you put a line parallel to that. Then you intersect it with this line, which is y equal to A. And then we are trying to find the equation of this line. Does that make sense? So we have that a square plus b square equal to c square. Okay, this looks Pythagoras, but it's not. Does that make sense?
So what do we plan to do after finding the slope of EG? How does that help exactly?
No, AG, no. So we are trying to find slope of AC.
All
It's
right.
equation of AC. Then we will intersect it to find get F. And like we hope to show F is the midpoint of EG. What was I doing? What is this?
But how do we like fulfill the other conditions also of H being the circumcenter? Like,
Yes.
yeah.
So it is my bad. This is like plus C by the way. So what I intend to do is, so now if you show F is the midpoint, you will show one thing. Then you like draw this perpendicular bisector, intersect with this thing, and if you show that the x coordinate of this is the midpoint of x coordinate of B plus G, you will be like done.
Ah, okay.
Okay. Is this correct? I am finding this a bit suspicious. I have messed something up. Wait, just a minute.
How did you get the step after by is equal to c minus ax plus bc? The one after that.
Oh, I just like copy pasted this equation. I didn't see the
Okay. Okay.
not to like intersect those two now. What did I miss? Right, something is wrong. Oh, my bad. This like x minus a minus c. Yeah, now it makes sense. I was not getting that. Minus x into a minus c. Right, let me like redo this thing. Yeah, okay, so this is like y plus a. Oh, sorry, what? Not y plus a. Yb. What am I writing? Yb plus c minus a into x is equal to what? Mhm. Minus of ab plus bc, right? Yes. I hope.
How are we getting this equation again?
Writing. AB gets cancelled. Sorry. Sorry. What?
From where are we deriving this equation?
Like I'm just simplifying this. I mean,
Okay.
it sounds very stupid. I'm messing that up. Okay, now it should be correct. AB gets cancelled. Right, I did not see that. Minus AC, minus BC, my bad. Is it now correct? What do you think? Yeah, it should be correct. So now if you put y equal to like A, to get G, you will get that G is what? Minus of BC plus AB upon C minus A comma A. And okay, now we will do this here. YB is equal to C minus A into X plus AB. No, sorry, plus minus BC.
So if we can show that EF equals to FG, we are done.
Sorry?
How did we show EF equals to FG?
Wait, your voice is too low. I can't hear you.
How did we show EF equals to FG?
No, we are showing that.
Hmm?
I mean, I intend to show that now.
Because if we show that, we are done, because then we can just have a homotheity of 2 around E, that around
Have we done? How are
if,
we done?
because you can just do a homotheity of E, right? So that will turn EFO into EGB.
EFO into.
ECF. Oh, sorry, EF.
Okay, that makes so much sense. Okay.
Right?
E
I agree.
EFO into EGB, right? You mean like
Yeah.
this thing.
Yeah.
So that would take this to this to this.
Wait, so
And you
OF
need
parallel to BG also works.
OF parallel to BG, yeah, we require that, yes.
Like the y coordinate of F is 0. Or wait, am I tripping?
Yes, no, we were getting that here, no? So like this is like minus C minus A into.
Wait, so isn't that just done? Wait,
Yeah, that's immediate, I think.
Yeah, so like you just solve this and get F is like midpoint of BG because you will get the y coordinate is 0. So you will get OF parallel to YG or BG, and then homotheity finishes. Why does O lie on that circle? Why does O lie on ECF का circle?
because of angle 6. We
Okay.
have
I am like trying to. Okay, sure. Okay, let's just like finish once without angle chase. I mean, angle chase, the problem is very easy. You don't need to code bash actually. Is it fine?
sure.
Yeah. Okay, so you will get that F is what? Let's just calculate. What just happened here?
So that gives By is equal to 0.
By equal to BC, no? You get X equal to 0.
Yeah.
And so by equal to bc. Y equal to c. Wait, what? I am.
No, you get by is equal to bc and by is equal to minus bc.
No, I messed up while writing it. Sorry. What am I doing?
It seems correct.
That's what seems correct.
The steps, even from previously, where we're getting the yb plus c minus ax is equal to minus bc.
Yeah, this equation is correct, no?
Yeah.
Even this looks correct. No, minus of that minus bc, so you add, but y equal to 0. Why is y equal to 0? Not x equal to 0. No, okay, wait, y equal to 0 is correct. What am I writing? Y equal to 0. I very sorry for the confusion. I am like glitching today. My bad. So you get y equal to 0 and x is equal to then a minus c, bc upon a minus c, right?
Yeah. That.
Now,
Slope, right?
yeah. Sorry,
This is the slope, right?
this is like the coordinate, no? Or no? Y, comma 0. Sorry. Like just put y equal to 0 here.
Okay. Okay.
Yeah, okay. Why is this not matching? OMG, what am I doing? Uh, so this should be like minus b to that. Okay, yeah, no, it's fine. So now if you just take the midpoint of GE, so clearly the y coordinate matches. The x coordinate we need to check. So it's like minus bc plus ab by c minus a plus, oh sorry, minus or plus. Yeah, plus.
Then the midpoint of G just F. What are we trying to do?
No, we are trying to prove that by coordinate.
Wait, what? Isn't that by just midpoint theorem or something?
It's midpoint. Okay, yeah, okay.
Like OF parallel to BG.
Yeah, okay, it's midpoint. True.
I
We-
didn't get it. How did we get EF equals to FG?
What?
How did we get EF equals to FG?
So we found out like the coordinate of f, no?
Oh.
But like, what was the midpoint theorem thing?
No, he just said that so OF is parallel to BG, right?
Uh,
OF is x-axis, BG is parallel to x-axis, so this is midpoint.
yes. Uh,
So one thing, sorry?
yes.
Yeah, so one thing you get is that this point lies on perpendicular bisector of EG. So now we just need to show that it lies on the perpendicular bisector of BG also. Okay, so wait, there will be. What was the slope of CB is this thing. So what we require slope is B by C minus A through F.
Isn't BE better though? Because like O is like the midpoint of BE, and then
Wait, what do you mean?
like we know like we just need to prove that the perpendicular bisector of BE intersects at like meets H. And O is just the midpoint of BE, so we can just like calculate.
Okay, sure. No, wait. But how will you then show that the point is the same as this H? I mean, how do you know that these 2 points intersect on BC? Like these 2 lines intersect on BC, they can like intersect somewhere here, no?
Okay.
Or what?
Wait, let me think about this. Okay.
Okay, no, true. Yeah, what you said is true. So you just like intersect these two, so you get that it is here. So you get this is 90 and you're done. Okay. Yes, that makes sense. Okay, wait, then why did I calculate F?
To prove OF is parallel to BG and the EF equal to EFG part.
No, but that thing is irrelevant if we just intersect these two on BC.
Wait, but then we have to prove that angle A and that H and F is 90, right?
Yeah, okay, true. Okay, I mean, should we complete that or we can leave it here?
I think we can leave it if everyone.
Yeah, okay. I mean, it's quite easy to finish. I had like one more setup for this, but I mean, let's not go there. I mean, this problem was actually like a pretty bad choice for coordinate, but I just like thought of taking it because it's nice coordinate. Okay, wait, how much time do we have? Okay, so we have like some time. Wait, we can do one more problem. Is it okay if I go like 5 minutes overboard or something? 5 10 minutes.
Yeah, that works.
Yeah. Okay. So this problem is like like many of us have seen this. This is like stems this year. Okay, and I sincerely hope not to make any stupid calculation errors this time.
Isn't the question you just gave angle chaseable?
Sorry.
Isn't the question you just gave angle chaseable?
Yes. That is like InMo 24 P1. It's like trivial by angle chasing. That's why I said it's pretty bad choice for coordinate, but I had like very less questions on coordinate, so I just thought let's take that. I mean, you don't need coordinate. You really don't need coordinate for that. I mean, it's trivial. That's why like you should. Okay, that's like one more learning. You should try synthetic whenever possible. Don't call. Okay, so this is like H, M, N, and then you have this reflection thingy. To show this is 90. Okay, any obvious setups, approaches?
I can't see, or is it just me?
Oh shit, I forgot again.
No, even I can't see it.
No, my bad. I forgot to like resume them. Okay, can you see now? You can see now, right?
Yeah.
Yeah. So like any obvious. Okay, I figured the problem. Also, the like flow of this problem is pretty unexpected. I mean, you really like translate every condition and just like finally get to a very basic thing.
Is it this year's stems?
Yes, it stems this year. I said that it stems 24
Okay.
or 25. I mean, whatever you call that. Has anyone caught batch this already?
I've complex bash data, not coil bash.
Okay, complex batch like doesn't count. As
Complex
called.
bash seems easier on this.
I mean, caught batch is quite easy. I mean, okay, both are
It's
quite
like
easy.
H prime is very easy, then N is easy, then the angle condition is just trivial. The
Yeah, I
tangent
mean,
C.
okay, so no problem.
ABN is isosceles, right?
ABN is not isosceles. Why is ABN isosceles?
Because BNM is equal to 180 minus ABM, so BNA is equal to ABM.
What? Okay, you mean this type of isosceles? Okay, I don't know. I haven't thought about it. This angle is this angle. Why is this angle equal to this angle?
I'm not saying that. I'm saying that A and B is A and B is equal to ABN. I'm saying because A and B is 180 minus BNM, and BNM is 180 minus A and B. ABN, right?
ANB you mean or AMB? I'm like not getting.
A and B, N for N.
Oh, wait, what do I do? ANB, right?
Yes.
And which is the vertex? I mean, which is the common vertex of isosceles?
A.
A. Interesting. Okay, why? So this
Uh,
angle is 180 minus this angle, but then this angle is this angle. No, okay, I don't see why. Why?
A and B is 180 minus BNM,
Yes.
and BNM is tangent to AM, AB.
Yes.
So BNM is equal to 180 minus ABN.
No, it's 180 minus ABM. It's like this circle. So this angle would be like this angle.
Yes. Right.
Okay, so I'll just like now give a sketch, let's say, then we'll do that. Okay, so an obvious setup why this is like you choose circumcenter as the origin and take BC parallel to x-axis. But why is that an obvious setup? Is that okay? So you can like take this A comma B or something. Okay. Yeah, I mean whatever. Then you can take this as minus. Let's take this something else. Let's take this as x naught comma y naught minus b comma c, b comma c. So m becomes like 0 comma c. So that's why m gets good coordinates. Also h you can just directly now add things up. So h becomes x naught comma y naught plus 2c by 2. No, not by y naught plus 2c. So now you can directly calculate h dash. H dash, like it's the reflection of h over b, right? Yeah. So that is like what is h dash? Interesting. So it's minus 2b minus x naught comma
How is y equal to y naught plus 2c?
y is
Y is equal to y naught plus 2c.
because like circumcenter is origin, right? So the coordinates of orthocenter is like the sum of all three.
Oh, you're taking circumcenter. Yes.
Yeah, so
Okay.
origin is circumcenter.
Yeah.
And so you also have that x naught square plus y naught square is equal to b square plus c square. Also, like let's take this plus and this minus because we don't really require c a lot. So this becomes plus 2b minus x naught, and then this will become 2c minus y naught thingy. So this will be like minus y naught, right? Okay, so now the interesting part is you don't really need to calculate n at all. So I'm going to like redefine n as the perpendicular from h dash to this point. So like take this as 90, and then I'm going to show that ab square is am into an. So now this is like the circle with so like I just have to show. So n belongs to circle with diameter h dash m. So this thing you can calculate easily. And the power of a in that you can calculate by just substituting. So power of a comma this circle is equal to AB square. That's all you need to show. So this thing you can like calculate directly by the diameter formula and then just substitute A's coordinates. You have to show that it's equal to AB square. Does that make sense? You don't need to calculate n at all.
Yeah. Yeah, that makes sense.
Yeah, okay. So I mean, let's do this very quickly. How do you do this? Okay, so this is like x plus x naught minus 2b into x minus x naught plus y minus y naught minus 2c into y minus y naught, y plus y naught. Sorry. Wait, how do you move this thing? Okay. So y plus y naught. So now you have to substitute the coordinates of x a here. So you will get that this is like 2x naught uh, minus 2b into, wait, why does it become 0? Did I miss something now? Oh no, oh wait, why did I take h as dash? Sorry. This is to be like hm. So x minus x naught plus 2b into only x plus y plus y naught into y minus c. So just substitute coordinates of x, you get that this is 2b into x. This is reverse. What am I doing? So it's like x naught into 2x naught minus 2b plus 2y naught into y naught minus c. This becomes 2x naught square plus 2y naught square minus you can just like take 2 outside or something. It doesn't really matter. This becomes 2x naught square plus 2y naught square minus 2bx naught plus 2 minus 2y naught c. And now you know that this is equal to 2b square plus 2c square. So like one of these you replace by b square plus c square. So then you get this is just equal to x naught minus b ka whole square plus y naught minus c ka whole square, that is equal to ab square. Done. Did that make sense?
Yes.
Nice. Okay, so this is it for today, I think. Unless anyone has any doubts or comments, questions. Okay, I'm like really sorry for the confusion I caused here. I messed up the calculations side. But
Wait,
this
for
is,
this question, like INMO 2024 P1, like we could like use C as origin. Like, is that better or like is it worse?
yeah, I mean, I was thinking about that. I mean, the thing I constructed later at home, like 1 year later or something, is that I use this something like of this sort. Like this is C, this is E, B, and like A is somewhere
Yeah.
here I care about. Then F and G. How to define G? Yeah, okay, you define G something like this. Yeah. And then you just show EFC and EGB thing. This was the setup I had used like I reconfigured this on like December or November sometime because I wasn't really remembering what I'd done on the contest. Yeah, okay. So okay, so the point is that don't code bash this on contest. I messed that up. I mean, I didn't miss code bash, but I missed the test because like this required a lot of time. Synthetic was trivial. So like don't really use code bash unless you don't see any other thing. Also don't overuse code bash. I mean, I used to do that a lot. There was a time I like used to use code bash a lot. It was the only thing I did. That's not good. That's not really good. Okay, that's it from my side. If anyone has any questions, comments. Well, let's probably stop recording.
Thanks for teaching.